All right, let's just jump right in. If you look at the entire history of physics, it's really been one grand quest to explain more and more of this wild universe we live in, but with fewer and fewer ideas. It's this epic search for the ultimate simplicity hiding underneath all the complexity. And today, we're going to look at a pretty radical new player in that search.
You know, the physicist Raphael Bosso put it perfectly. He said that physics is basically a history of unifications. It's all about finding these deep, hidden connections between things that, on the surface, look totally separate. This drive, this need to unify, is what powers physics, and it's brought us right to the edge of the biggest challenge yet.
I mean, think about it for a second. Back in 1687, Newton has this incredible realization that the force pulling an apple to the ground is the exact same force it's keeping the moon circling the Earth. He unified the heavens and the Earth. Then, fast forward to 1915, and Einstein comes along and weaves space, time, and gravity into this single, beautiful fabric called space-time. Every one of these steps gets us to a deeper, simpler truth, which of course brings us to today and the final frontier, trying to stitch together the bizarre world of quantum mechanics with the cosmic force of gravity.
So, keeping that grand quest in mind, let's get into the first part of our story here. We are about to look at a brand new idea, a framework that suggests a single, kind of stunningly simple principle might just tie it all together.
So, what would that even look like? Well, what physicists are really hunting for is something you could think of as a new Rosetta Stone. You know, a single powerful key that could let us translate between the completely different languages of the quantum world and the cosmos. So let me just throw this out there. What if there was a single value, just one number, that could act as the key to some of the universe's most profound mysteries? A number that could explain why time marches forward, how reality itself changes when you zoom in or out, and maybe, just maybe, what gives our universe its very shape. Well, let me introduce you to our hero for today, a value called the spectral gap. We use the Greek letter delta for it. The best way to think about it is like a cosmic balance sheet for information. On one side of the ledger, you've got information being lost, decoherence, like a picture fading over time. And on the other side, you've got information fighting to be rebuilt or held together. The spectral gap, it's just the bottom line. It tells you the net result of that constant battle.
Yeah, think of it like a cosmic tug of war happening everywhere all the time. On one team, you have projection. This is information loss or decoherence. It's where a system's clear quantum state gets all scrambled and just sort of fades into the background noise. But pulling on the other end of the rope is integration. This is the system's power to fight back, to reconstruct itself, to hang on to its sharp, coherent state. And the spectral gap? Well, that's just the final score. It tells us point blank who's winning.
Okay, so we've got a cosmic scorekeeper for information. That's cool, but what does it actually do? Well, its first trick is a pretty big one. This one number might just hold the secret to one of the deepest mysteries there is, the arrow of time.
And the logic is actually really clean. Check this out. If a system has a positive spectral gap, right, that means information loss, projection, is winning the tug of war. The system is constantly losing its structure, getting messier, more disordered. And what do we call that relentless one-way street toward more and more disorder? We call it entropy. And it's entropy that gives time its direction, its forward arrow. So a positive spectral gap could literally be the fundamental engine that's pushing time forward. Now, explaining the flow of time, that's a huge deal. But the spectral gap's influence might not stop there. The theory suggests this number also acts in really fascinating ways depending on your point of view, whether you're looking at things down at the tiny quantum level or up at the grand scale of the universe.
And what this theory predicts is just fascinating. Depending on how you zoom out from a system, physicists call this coarse graining. The spectral gap's value actually changes. It's kind of like looking at one of those pointillist paintings. Get up close, and all you see are individual dots. But as you step back, a coherent picture emerges. It's the same idea here. In what's called the subcritical regime, coherence wins and order can emerge. In the supercritical, chaos wins and things fall apart. And right there on that razor's edge is the critical point, a state of perfect, delicate balance.
So we have a number that might be driving time and defining how things behave at different scales. But now we get to the most mind-bending part of this whole idea. Seriously, buckle up. We're about to see how the spectral gap might not just describe reality, it could be the thing that literally gives reality its shape.
To get our heads around this, let's do a little thought experiment. Just imagine a map, but instead of cities and roads, it's a map of pure information. And at every single point on this map, there's a number, a specific spectral gap value telling you exactly how fast information is fading or forming right at that spot.
Okay, here's the leap. It's a big one. We all know that massive things, like our sun, literally bend and curve the fabric of spacetime, right? That's gravity. Well, this theory proposes something very similar, but for information. It says that sharp changes, or gradients, in the spectral gap from one point to another can actually bend and curve the very space of information itself. To put it simply, the geometry of our universe might just be an emergent property of how quickly information fades away in different places. Wow.
Okay, that is a wild, fascinating, out there idea. But, like any new theory in physics, we've got to ask the most important question of all. Is it science? Because the difference between just a cool idea and actual science is that science has to be testable. You have to be able to prove it's wrong.
And that's the beauty of this model. It lays out some very sharp, very clear ways it could be shot down. For instance, if scientists ever find a system where information loss is winning but its entropy goes down, the theory is just wrong. Toast. If they measure how fast a quantum system decoheres in a lab and that number doesn't match the predicted spectral gap, the theory's wrong. These aren't just vague philosophical claims. They are concrete, testable, experimental predictions.
So it leaves us with this final, really provocative thought. If the universe, at its most fundamental level, is really just processing information, if it's a kind of grand computation, then this whole framework suggests that we might have just stumbled upon a key parameter of that cosmic computer. A single number that doesn't just set the direction of time or the shape of information, but might actually be the fundamental clock speed that drives reality itself. What do you think?